Hi, I am Valerio Basile from the University of Turin, Italy, and I am presenting my work towards automatic screening for fibromyalgia in Italian social media users. What is fibromyalgia? Well, it is a condition or a syndrome that is characterized by pain all over the body and problems with sleep and memory and other cognitive issues, fatigue, and also mental and emotional psychological distress. Typically, people that suffer with fibromyalgia are more sensitive to pain, and this is by the definition of the Center for Disease and Control Prevention of the United States. What causes the fibromyalgia is still largely unknown, although there has been a lot of research in the medical literature. Worldwide, it is estimated that about 2 to 4% of the population may suffer from fibromyalgia, and this is a conservative estimate. And also the incidence of this syndrome is more in the women than in the men, about 2 to 1 ratio. In Italy, the situation is not very different. About 2% of the population is estimated to be suffering from fibromyalgia. That is to say that this is not a rare condition at all. In this study, I was interested to understand through the language that people use on social media in Italy and in the Italian language, whether it is possible to understand their relationship with fibromyalgia. In particular, I focused on Twitter and the Italian Twitter sphere, with the goal of understanding and analyzing if there is some common patterns in terms of topics, what people talk about on social media, and even if there is the possibility of creating some kind of automatic tool that discover or screens for fibromyalgia on social media users. In order to carry on this study, I downloaded data from Twitter. I downloaded a series of tweets in several steps that I will detail in the following. To start with, I searched for the word fibromyalgia, the Italian spelling of the word, on one particular day. It was December of last year. Particularly, I used this query that is shown here. So I excluded retweets, replies, and quotes. I also excluded everything that has links or multimedia content, images, videos, and so on. And with this first step, I retrieved about 1,500 tweets. Then I went through a step of manual selection where I identified 339 tweets among these that were sent from 148 authors, which self-declared to be suffering from fibromyalgia. That means that they had to either declare explicitly to have received a diagnosis, something like, I was diagnosed with fibromyalgia, or they could imply it, but very clearly, something like, following my diagnosis, etc. And sometimes also hashtags are signals, but only if they are very unambiguous. This is a slide showing a few examples of this with the translation in English. So you see something like, I suffer from a rare condition called fibromyalgia. So this is very explicit. Or in the second tweet, it says, sometimes fibromyalgia takes my body. So again, the syndrome is named very explicitly. For the next step, I went back to the Twitter API and I downloaded all the tweets from the users that I identified in the manual selection step. And this time the users are 145 because for 3 users I couldn't find any tweets anymore. Again, I excluded retweets, but this time I included the replies because I am interested now in all the tweets produced by these users. And in total, I retrieved about 250,000 of tweets. Finally, in order to balance the collection, I sampled just 300 tweets from Twitter, which is a large-scale collection of about 10 years of tweets in Italian language without particular topical focus. And again, I manually annotated the users of these tweets in order to exclude tweets sent by non-individuals. So, for instance, tweets sent by organizations, associations, or newspapers, and something like that. And from this result, I selected 145 users, so the same number of users as the previous step, and I retrieved about the same number of tweets from these users. And this is a summary of the full process that I just explained. And in the end, with all these steps in place, I end up with a final dataset of tweets, about slightly more than 500,000 tweets in Italian language, balanced with respect to the users. So I have about 145, exactly 145 users that somehow have declared to be suffering from fibromyalgia, and the same number of control users. So with this dataset, I set up a simple text classification experiment. And these are the tools I used. I used a library for Python called Tweet Preprocessor just to clean the tweets, removing URLs and mentions. They were replaced with special tokens. I also used UDPipe version 2.5, which is a pipeline for natural language processing, which I mostly used for tokenization and lemmatization. And for this, I used one particular pre-trained model, which is based on the tree-bank post-Twitter, because that is specific for Twitter language in Italian. So, with the goal in mind of creating a classifier for users, I extracted 3 families of features. So 3 different vectors for each user in my dataset. The first one is engrams. So I ran a TF-IDF based count of token engrams, where the engrams could be unigrams up to 4 grams. Then the second set of features is based on LIUC, the Linguistic Inquired Word Count Dictionary, or better, the Italian translation of it, which comprises 85 word categories. Therefore, this second feature vector is 85 dimensional. And finally, I also used BERT pre-trained model called Alberto, which is pre-trained on Italian Twitter language, and encoded all the tweets for all the users, and then averaged for each user the embedding of all of its posts in order to come up with about 700 dimensional vector representing all the posts of a user. In terms of the actual classification, I ran a cross-validation experiment, tenfold. And for classifier itself, I used a random forest classifier, so nothing too exotic there. And again, I recall that the unit of prediction is the user, not the text. So I am classifying users as whether suffering from fibromyalgia or not. These are the results of the tenfold cross-validation experiment. As we can see here, the best classification performance as expected, is obtained by birth, followed by looking at the individual features, n-grams, which is the n in the first column, and while using only the Luke features achieves the worst performance. But if we combine n-grams and the Luke features, we get an improvement, which means that they're somehow complementary to each other, which is also what is explained in this slide. Now, of course, the embeddings perform better because the pre-trained model of Alberto is way more informative. It's a very large model. But it has the problem that the embedding model, BERT, is difficult to explain. So we don't really know what are the features that lead to a certain classification. While for this study, I was also interested in the interpretability of the model. And the n-gram features and the Luke features are actually interpretable. There are ways with the random forest classifier to understand which features are more important for the final classification. And this is what I actually looked at. There are more details in the paper. I just show a few highlights here. For the n-grams, I found that the top n-grams that are more informative for the classification are all linked to pain, so dolore, dolori, or some kind of negation, like I don't, I can't, stuff like that, which I think is very interesting with respect to the specific phenomena I'm looking at. Similarly, for the Luke features, they are 85 features, and if we rank them by their importance for the final classification, at the top of the list we find something like body, human, home, self, etc., which indicates that the language of the users suffering from fibromyalgia is centered on themselves, their body, their health, but also their life in general. On the other hand, the classification performance of Alberto, so of the BERT model, is quite high actually, and in particular there is we measure a high precision on the positive class, so there is a high precision when classifying the users suffering from fibromyalgia, and it could be even tuned further. For instance, we can modify the threshold for the activation function and stuff like that. And that, I think, paves the way, even though this is just a preliminary study, for a system that does some kind of automatic screening on all the Italian Twitter sphere, because this is now fully automated, for the purpose of some kind of medical screening and perhaps notifying users that they may want to be checked if they talk in a certain way on their Twitter. Thank you for listening.